Hello guys, welcome to my channel Civology, the study of civil engineering. Today our topic is about quantity of concrete in square or rectangular column. We will calculate these values or these quantities in kgs and cubic meters. So this is going to be very simple, easy and fast. And the ratio we are going to use for concrete is 1:2:4, which is the equivalent of M15 grade concrete. So you are requested to watch complete video for better understanding of the topic, and if you are new to my channel, please subscribe it and don't forget to press the bell icon to get video updates. So let's start our today's topic. So guys, first of all, let us assume before we start our today's topic, I have made a multiple, you can say a number of videos on this topic, that is for different grades of concrete in 1 cubic meter, for M15, M10, M7.5 grade concrete. The link of those videos are given in the description. If you get able to know that how much concrete is required in 1 cubic meter of concrete, you can calculate it for any volume. Okay, so the link is given in the description. Let's assume the height of the column is 3 meters, as you can see over here, and if we consider the cross section of the column, its dimensions are, one dimension as you can see over here is 0.6 meters and other dimension is 0.4 meters. Let's say the first dimension is dimension x and it is 0.6 meter, and other dimension is dimension y, which is 0.4 meters. Now the first step is to find area and volume of the column. Okay, as this is a rectangle and its area is simply the one dimension multiply with another dimension, so the area will be 0.6 multiplied by 0.4, which is equal to 0.24 square meters. For concrete calculation, we need to find the volume of that section. Okay, and the volume of column will be 0.24, that is area multiplied by the height of the column, so the volume will be 0.72 cubic meters. Now this is the total wet volume of the concrete. Okay, but we usually take the ingredients of concrete, which is cement, sand and aggregate, and they are usually in dry form, and dry volume is more than wet volume, so that's why we use this constant, which is 1.54. It's mean that the dry volume is 1.54 times of wet volume. This is called as shrinkage or dry constant, and it is more as compared to wet volume. As I told you before, we usually mix the ingredients in dry condition, and when concrete gets hard, it shrinks. To cater this shrinkage, we use value between 1.54 to 1.57. Okay, so it comes out to be 1.11 cubic meters. This is the dry volume of the concrete for which we are going to make further calculations. Okay, and let's assume the mix ratio is 1:2:4 and M15 grade. Okay, sum of the ratio is 1 plus 2 plus 4 is equal to 7. Then we will use this formula for calculation of each ingredient, that is if that is ratio of ingredient multiplied by dry volume. This is dry volume. Okay, divided by sum of ratio, which is 7. So the quantity of cement will be equal to, that is ratio of ingredient, which is cement multiplied by this value is for dry volume, cement value, the value of cement is in this ratio. Okay, which is 1. Okay, multiply by dry volume divided by sum of ratio, which is 7, and it will be equal to 0.158 cubic meters. Now if you want to calculate the number of bags, divide this value with 0.035. Now this is the volume of one cement bag. Okay, and it is equal to 1.25 cubic foot. In feet it is 1.25, and in cubic meter it is 0.035, the volume of one cement bag. Okay, you will get the number of bags, which is 4.5 bags. Okay, now the quantity of sand is equal to 2 multiplied by 1.11. As you can see over here in this ratio, 2 is for sand. Sand is 2 times as that of cement. So 2 multiplied by this is dry volume divided by sum of ratio. It will be equal to 0.361 cubic meters. Similarly, for crush or coarse aggregate, we will use 4. As you can see over here in this ratio, 4 is for coarse aggregate or crush, and this is dry volume divided by sum of ratio. It will be equal to 0.632 cubic meters. So these are the values that we have calculated in cubic meters. Now if you want to convert these values to kgs, you must know the density of cement, density of sand, and density of crush that you are using in the concrete mix. Okay, so normally the density of cement is taken as 1440 kg per cubic meters, which means 1440 kg per cubic meter, and the density of sand is between 1520 to 1680 kg per cubic meter, and the density of crush or coarse aggregate is 1200 to 2100 kg per cubic meters. Now here to have you have two options, that if you multiply this volume with the density of cement, you will get the weight, or you can say the mass of cement in kgs. Okay, which is 272.52 kgs. Now here you have two options. Simply multiply this value with 2, as the ratio we are using is 1:2:4. 2 is for sand. They multiply this value, you will get the quantity of sand in kgs. If you don't know exact value of density, then do this. Okay, and for crush, as you can see over here, crush is 4 times as that of cement. Multiply this value with 4, you will get the quantity of sand in kgs. If you know the exact density, then follow this method. Okay, multiply the volume of sand that we have calculated in previous slide, multiply it by density of sand. Okay, which is 1500 kg per cubic meter, and it comes out to be 474 kg. Okay, and if you know the density of crush or coarse aggregate that we are using in concrete, multiply it with density, volume multiply by density, you will get the quantity of cement crush in kgs. So that's how you can find the values of ingredients that we are using in concrete in kgs and cubic meter. So that's all for today. For further videos, you are requested to please subscribe the channel, and don't forget to press the bell icon to get video updates.